Hello and good morning, and thank you for coming and joining me here in my shop. Today is the Ides of August. It's the 15th of August. And what are we going to do today with this radio? So I think now might be a good time to test the tubes that are in the radio. And I'm just going to test them on my tube tester, which is sitting right here. And we will find out if maybe some of the lack of performance is coming from a weak tube in the radio. So I'm going to go ahead and get the first tube ready for testing. Okay, so the first tube we're going to test will be the rectifier tube. This is a 35Z5 tube, and I'm going to set the machine up for it here. 35Z5. So 35 volts on the heater. No need to set the signal level. No need to set the bias. It's a rectifier tube. 35Z5 07003. And 0610. 0610. 23. And the plate is set to E. These should be up. Okay, we're ready to go. Quick double check here. 35Z5. 23E. That's good. Okay, in it goes. Now I think if this tube were a little weak, what happens to it is its own voltage drop starts getting bigger and bigger. More voltage dropping through this guy, less voltage left for the radio. So ultimately the radio will get quieter and quieter. And eventually it will just stop performing. But that's probably not the case. It's probably going to test good. We're looking for shorts right now in the tube. There are none. Okay, so to do this test, we're flipping this button that says rectifiers and diodes. And we're expecting it to come up above this limit here, where it says rectifiers OK. I don't know if you can really read that. No, you can't read it. But just pass my finger and we're good. Here we go. Yeah, way past my finger. Okay, so this tube, no problem with it. That's one of the two tubes that tends to wear out early in the life of a radio like this. The rectifier tube and the output tube, which I'm getting next here out of the radio. The output tube, those two tubes work hard, and 50L6, just as it should be. Okay, let's keep going here. I'll just do the whole thing here. 50L6. Set voltage to 47 volts on this machine. Signal level 8. Bias set to 18 high, 18H. 07345, 07345, 0610, 0610, 43, and the plate is on C. For this tube to be still have some life left in it, I guess you could say, 1030. So just above the 1000 mark, just above my finger here. Okay, quick double check. 50L6, 47, 8, 18H, 07345, 07345, 0610, 43. There we go. So if this tube got weak, all that would happen is the volume would drop off, and maybe some distortion might be heard. You'd end up not even realizing it at first because you just compensate with the almighty volume control, the control that solves all problems. I used to fix my car in the same way. I'd be driving down the road and my wife would say, gee, what's that noise? Back in the day when I drove junk pile cars. What's that noise? I'd say, what noise? And I'd turn the radio up. There's no noise. Hey, it worked every time. Here we go. Ooh, just go over here. Looking for a short. I wouldn't expect to find one. A short is a serious problem in the tube. If you have a shorted tube in the radio, there's going to be serious problems in the radio tube. This time we're pushing the transconductance test, or mutual conductance test. In this tube tester they call it mutual conductance. And we got to get up above the 1000, which is here. So it's right on the 1000, smack on the 1000. So this tube is fine for a radio of this vintage. These tube testers were set up in the day where part of the business was selling tubes. I'm not going to suggest for a minute that there was something untoward going on with tube testers. Tube tester operators, well, that might be a little bit of a different story. You're going to make money selling tubes. You got to tell people their tubes are bad. 12SQ7 is the next one. So I'm going to get that all set up and we'll do it. That was the last of my coffee alarm going off, but I'm going to skip the coffee for now. 12SQ7. 12SQ7. 2 tests for this tube. So 13 on the heater voltage setting, signal level 1. 18L for the bias. The numbers are 25100, 25100, 3760, 3760, 37F. We're good to go. Here we go. So this tube is the detector tube and first audio amplifier. If the audio amplifier is weak, the output volume would be weak. And this radio, the volume's not actually weak. Actually, lots of volume. What's weak is the reception. May not be related to, well, probably, I'm guessing, probably isn't related to the tube at all. Let's find out if this one stacks up. So first we're testing the triode audio amplifier in here. And it should come up just above 760, which is about here. Oh yeah, that's a beauty. Okay, next test, I'm going to pull it out while I change the settings, is to test the 2 diodes that are in. They're tested separately, but with one setup here. So that doesn't matter, that doesn't matter. We're doing a diode 2013P. 2013P. 0760. 0760. 48. Over to A. Okay, plug this back in. Give it a moment to warm up again. So the diodes are responsible for rectifying the output of the IF, commonly called the detector, which is really just a very, very old term back in the day when radio was first being discovered. Radio waves were first being discovered and experimented with, and they needed some way to detect the waves. So they needed a detector. That's where the term comes from. Today, yeah, it's a little misleading in a sense. It's really just a rectifier, and I won't go into it any further. Here we go. No shorts. Okay, so this guy, we're going to be testing a diode. He only has to come up past my finger here to be considered good. So first diode test. Wow, actually it's just below the limit. Okay, and we flip plates, I think. Do we not? Yes, P2. Different plate now. Testing again. This one's up in the clear zone. So in this radio, both these diodes are just put in parallel. It's like one big diode instead of 2 that are actually in the tube. One of them's testing weak and the other one's not so weak. A little odd, I would think. Why would they test differently? You'd think whatever's happening to one is happening to the other, so they test the same in the end. Now, could this be a problem? Gee, I don't know. To be honest with you. it's, one is testing good, the other one's still functioning. It's not like it's broken or something like that. So I think again that tube is going to be okay. 12SK7. This is the IF amplifier tube. Okay, I think I'm just going to let the video roll here. 12SK7. Okay, so the heater voltage is number set to 13 here. Signal level 2. Bias is 10L. The numbers are 17251. 17251. 4630. 4630. 44. On the sensitivity, meter sensitivity, C is the plate setting. There we go. Single. Okay. This tube is very important for the ability of the radio to amplify the radio signals it's receiving. It's not an audio amplifier, it's an RF amplifier. If this one's weak, that might very well explain why the radio doesn't receive well. Let us find out. Short test. No shorts. 12SK7 should come up to 1520 on the meter, which is just past halfway. So halfway. Oh, what happened there? I'm not sure what happened there. A couple of readings just kind of flubbed. But the tube is checking out really well. So this is a good tube. Well, there's only really there's only one more left. And this tube, let me just put this one back here. This tube has also an important job. They all do. This guy here, where's the number? Sometimes they put it right in the base. There's no number on this tube. Looks like it's right in here and it's been wiped off. Uh-oh. Well, it's very unlikely this is the wrong tube. If yeah, there's no indication of what it is. So a good assumption is it is what it's supposed to be. And what is that? What is that supposed to be? So I'm just going to stop for a sec here. Okay, we're all set here. Let's just double check. Now this tube here in North America is called the mixer tube. 9L. 27345. 27345. In Britain, this is called the frequency changer tube. And that's a much better thing to call it. 1650. 1650. 45, because that's what it's involved in. It's involved in changing the incoming frequency of the radio station you're listening to, changing it to the IF frequency. Here we go. The special thing about this tube is it has an extra grid in it. It has, I think you would call this a pentagrid. If I've got it right, penta for 5 grids, pentagrid converter. It can also be called a converter tube because it's converting frequencies. Okay, here we go. This tube should come up 1100, so past the 1000, up about where my finger is. Way over. Way over. She's a beauty. Well, that ends the the tube testing for this radio, all the tubes are in good shape. Now, my common experience in doing this is you might have one bad tube. Normally, most of them are in good operating order. Not necessarily, but well, there we are. So we know the weakness in this radio's ability to receive is not related to a component problem underneath. The next thing I think I might be interested in checking out with this radio is its alignment. Even though it's early in the repair process, I've still got lots of old capacitors in there. They're not, well, the old wax ones are not likely to affect the tuning of the radio. So I can do a little alignment stuff now, and it will still be useful down the road. Why does this look so odd? Oh, I see. Okay, just me. Okay, so we'll do this at least. Play the radio and test the alignment. See if it's weak and needs attention. But first, my delayed coffee break. So what I'm interested in finding out is the IF way out of alignment. So that's just going to be kind of a rough check here. I'm going to do it. I'm going to tune in that station, the one station it gets, and then I'm going to try to peak it up a little bit, just using my ears and a little tiny screwdriver, and see if we can see if it gets better or worse. This is not a recommended thing to do normally, but I think if I'm careful, I won't muck it up too badly. Where's that station? There it is. Okay. That's about the best antenna position there. Start with the second IF, and I'm just going to twiddle the adjustment a little wee bit to see if things get louder or quieter or what happens. There's a lot of dirt down in here too. Okay, it seems to be right at the peak. Peak volume, this one here. Last one. Aha! Aha! Found one. Surprising to me in a way. Okay, now let's see if we can pick up something else. Did that make that big a difference? We can get something else on this radio. That motorboating sound is not the radio, that's an actual interference signal. 590. It's another interference signal, I think. Another one. A lot. And now the French speaking station. Not going to get it. Okay, so now I know the IF is aligned a little better in the sense that all these transformers, the four coils are aligned. We don't know what frequency they're aligned on. They could be no longer 455, it could be 465 or something like that. The main effect of that is it throws the tuning dial off, and not much else goes wrong. I think if you get the IF tuned off the target frequency. So there's a couple more adjustments down below here, which I didn't touch yet. One of these will be oscillator. Maybe they're both oscillator adjustments here. I'm not sure. And then there's going to be a couple of antenna adjustments somewhere. I'm looking for them. I do not see them, but I'm sure they must be in here somewhere. Unless these are them. And okay, what do we got to do now? We got a radio that works, just doesn't work that well yet. It's still full of these bad guys here. So we'll continue with this. Up here now. Who to do next? That's an interesting question. We could clean out the audio end of it. Just get rid of this and this. I think the audio end of this radio is good to go. One of these may not even be really an audio type capacitor anyway, but we could do these two and get rid of them. Or we can go right at the radio part. Where do we do these guys? Do these two here. Next. Okay. Sounds like a plan. Okay, so if we look here in the schematic, here's one of the capacitors that I'm considering. And look at its position here. It's tied to the B minus line. And the other end is tied to the start of the heater chain. So here's the heater chain, and then through all the other tubes down to here. It's as if it's attaching through the capacitor from a AC point of view, not 60 cycles, but let's say RF or something like that. It's tying this end of the string back to the B minus, but the other end of the string is tied directly to the B minus. Why would they do this? And I think I've got another schematic. It's extremely similar to this one. It's in a book. Shockingly similar, in fact. Shockingly similar. And we can look at that. I think the way it's laid out, it's just a little easier to see what's going on here. And I gotta warn you, my ideas are a little foggy here, so I could be saying things that aren't actually correct. Okay, so I'm going to show you my book here. I have a lot of books on radio repair. This one is the granddaddy of them. This is a great book. Elements of Radio Servicing. It's a thick book, and it goes into a lot of detail that many other books don't. A lot of other books, they just kind of go over the surface of everything. So this diagram is very similar to the one we were just looking at. So there's the rectifier tube, and then the rest of the string is shown here. There's the capacitor. Now that symbol means connect to B minus. That's what that means. There it is there. So you see either end of the string is connected to B minus. This end's done through a capacitor. The thing that stands out in this diagram is that between the power supply here and the radio is only one wire. And what this kind of highlights is just how isolated the radio is from the heater string. The heater string is just connected right across the power line, and the radio's on the end of a power supply with filtering and whatnot. And of course this is DC up in here, and it's quite different. I think what's basically happening, and I could be wrong about this, is disconnect a little like an antenna connecting from the B minus here, and as you go through it, you get farther from B minus. Eventually you attach to a wire leaving the radio and going out. And this could bring in signals from the outside world, I think. So you stick a capacitor here to capture those signals and or delete them or attenuate them, or pick your word for it. So you take this away and you're gonna maybe pick up interference more than if this were good. Now this radio is picking up interference. Interference signals are very powerful these days in our houses. Not like back when, back in the day. Oh, look at this book. I'll show you this. So I didn't write this. Power is like sex. If you think it's sinful, you don't enjoy it. And you're not much good at it. This is full of this stuff. I have no idea who wrote this. I got this book along with some vacuum tubes from somebody. They just handed me this book. Basically, I was, here, I have this book too. Alcohol and inflation are very much alike. The first effects are pleasant, but no one would consider running his business intoxicated. What's it got to do with inflation? Anyway, a lot of weird stuff in here. The system subscribed to by some governmental regulations and agencies, such as the Children's Aid Society, has been found more satisfactory than the forceful actions of history, such as the Crusaders, the Torquemada, Oliver Cromwell, and others, in an effort to have their particular brand of Christianity prevail. Boy, that's kind of interesting. I won't go into that at all. Yeah, weird book, but fantastic book in here. For learning how to fix radios. So I think that's what it is. It is a capacitor whose job is to drain out or prevent, block, kill, nullify, whatever it is you might want to... oh my gosh, what is this? It's the cover story. The counter tells you how far you should have gone at any given instant. There's the guy, he's got his Rally computer. What year is this? Radio Electronics magazine. It's the cover story. These guys put a computer in his car to help him with rallies. Don't rip it, don't rip it. Oh, how to fix radios faster and make more money. Listen to this guy. Yeah. Just a dead tube. Oh well, we gotta have fun looking at this old stuff, but we won't. We'll get back to what we're doing. So, conceivably, if this capacitor, this is the one we're talking about, if this guy's not doing his job, then the radio is going to be more susceptible to interference signals conveyed into the radio, into the heater string, and then out of the tubes into the rest of the radio to cause havoc. Havoc, I tell you. So we'll change this. My guess is this capacitor is working just fine, doing its job, and changing it isn't going to help out, but that's my guess. So let's go after it. Well, it's a nice looking capacitor. A little dry, little open on the end there, maybe. Let's just do something I don't normally do. We'll test it with this meter. I think this meter is quite accurate, but it really relies on a capacitor that's in good shape. We don't know the shape of this one. Let's see what it says though, before we put it on the bigger tester. So it says it's a 40 nanofarad. That'd be a 0.04 capacitor, and the V loss 10%. 0.04, but it's really rated at 0.02. So that is an indication to me on this tester that this capacitor is leaky. So it's really a capacitor with a resistor in it, and that tester gets fooled. And I think they all get fooled. They all get fooled in this situation. But this guy, he's built for this duty. This particular tester here we're going to use. So often there's wax on the wires close to the capacitor, and you need to kind of cut through it a little bit, which is why I do the wiggly thing. Okay. Too much junk on the floor here. Oh, jeez. Okay, that's good enough. There we are. Good enough. Okay, looking for the open pie. Starting with what is actually 50 volts. Here we go. Not opening very well. So that's an interesting question now. There's some amount of resistance in this capacitor. It's going to leak. It's going to leak. I don't know. I don't know what to think. What that would do. I'd have to stop and think about it. But I really don't want to stop and think about it right now. We're going to replace it. The clip lead showing where it came from. And I'm going to put a new 0.02 in there, provided I can find one. Well, it's a nice looking capacitor. A little dry, a little open on the end there, maybe. Let's just do something I don't normally do. We'll test it with this meter. I think this meter is quite accurate, but it really relies on a capacitor that's in good shape. But we don't know the shape of this one. Let's see what it says though, before we put it on the bigger tester. So it says it's a 40 nanofarad. That'd be a 0.04 capacitor, and the V loss 10%. 0.04, but it's really rated at 0.02. So that is an indication to me on this tester that this capacitor is leaky. So it's really a capacitor with a resistor in it, and that tester gets fooled. And I think they all get fooled. They all get fooled in this situation. But this guy, he's built for this duty. This particular tester here we're going to use. So often there's wax on the wires close to the capacitor, and you need to kind of cut through it a little bit, which is why I do the wiggly thing. Okay. Too much junk on the floor here. Oh, jeez. Okay, that's good enough. There we are. Good enough. Okay, looking for the open pie. Starting with what is actually 50 volts. Here we go. Not opening very well. So that's an interesting question now. There's some amount of resistance in this capacitor. It's going to leak. It's going to leak. I don't know. I don't know what to think. What that would do. I'd have to stop and think about it. But I really don't want to stop and think about it right now. We're going to replace it. The clip lead showing where it came from. And I'm going to put a new 0.02 in there, provided I can find one. Okay, got that capacitor in. Good. So I was talking about end of the assembly line. So I was a scout leader, even though I didn't know what I was doing. But I was a scout leader because I had 2 boys. One of the things we did was we went for a trip to the very large General Motors factory in Oshawa, Ontario, to see their operation. They were building trucks, I believe. So we go on the tour. They take us around. They show us different things. And then they show us the very end of the assembly line. So at the end of the assembly line, when the finished vehicle is coming off, a driver gets in it and drives the vehicle, well, going to drive it out to the storage area for eventual delivery to a dealership or something like that. But what they did is they get in the car, start it, and then they drive it quickly down this short straightaway, maybe 15 or 20 car lengths, long inside a factory, but short from a road point of view. Bring the speed up to, I'm guessing, 40 kilometers an hour, which is pretty fast in such a short distance. They really boot it. And then to my horror, slam the car into park. And you can hear it go, and you can see the car stop and lurch like this, or the truck or whatever it was. and then they put it back in drive and drive around. They do that just at the end of the straightaway, and they drive around. Now they had a choice at that point. They could drive around and just drive out, assumably into a huge parking lot somewhere, and the car was ready for delivery. Or they would turn sharper and drive into a repair bay. There were 4 or 5 repair bays sitting, and cars were in these repair bays and guys were working on them. And those are the cars that for some reason had something substandard about them. Well, I don't know what it would be. I don't know how they noticed it. I don't know where they registered it. Maybe even much earlier in the building process, maybe they noted something about the car that would have to be dealt with at the end. But anyway, one after another. I kind of wonder, well, what happens if the park doesn't, click in? And my God, weren't we all taught never to do that? Never put your car in park when it's still moving? Yeah, okay. Let's test this radio. Too much fun remembering things from so long ago. Okay, volume switches on. Okay, watching the dim lights because we've done something to the radio. Here we go. No countdown or anything, just right there. Just right there. Okay, all looks good. What are you going to do this time, Mr. Radio? Okay, I think it's warmed up. Let's go after the station we've been listening to. Hello? What is that? Radio did that last time, right in this tuning range. I've never heard that before. Nice quiet white noise there. Okay, French station, can you do it yet? No, I don't think so. We'll go way up here to 1010. No, not going to do it. Okay, so we're still a single station radio here. This is 590 and you can see it's not in the right spot. Oh, wait a minute, is it? 7, 6.5, so it's pretty close. Well, I can't say I heard any great improvement there. Perhaps a little less noise, perhaps. Interference type noise. Okay, I think that's going to be it for today. Tomorrow I'll carry on with that other capacitor that was up in that end of the radio. And we'll just plug our way through them until they're all gone. And the radio will work fantastic. Will it? Will it? I guess we'll see. Thanks a lot for watching, and I'll see you on the next video.